Welcome back. This is the day the Lord's made. Let us rejoice and be glad in it. Spend a few minutes talking about potential energy, kinetic energy for physical science class. Potential and kinetic energy are two different ways to describe energy. All energy is measured in joules, which is the unit of energy. Potential and kinetic energy are not conserved, but they can change forms. Like, for example, if you drop a ball, the ball speeds up. The ball had potential energy, and that energy turns into kinetic energy. It speeds up as it falls towards the ground. So when you think about potential energy as being something that's stored energy, like if you had some food, that's stored energy, or by virtue of location, where's it at? If you lift something up in the air, it has energy by virtue of being lifted up into the air. So other examples include chemical energy, elastic, like springs storing energy, nuclear energy. So we're going to focus on two forms of energy in this class for potential, gravity and food. So when it comes to gravity, the amount of energy it has depends on how strong is gravity. So if you go to another planet, you might have more or less gravitational potential energy. Like on the moon, gravity is a little weaker, so you can jump a lot higher. On Jupiter, it's a lot stronger, you won't be able to jump as high. It also depends on how high the object is. And you know this from when you grow up and you climb trees. The higher you climb the tree, the more scared you might get because you have more energy. And then it depends on how heavy you are. The more massive the object, the more energy it has too. On Earth, gravity is 9.8. So we're going to use this number when we do our calculations. And so connecting all these things together, potential energy is equal to those three things times each other. Depends on how heavy are you, what's the strength of gravity, how high are you. So it's just mass times gravity times height. So a sample question might look like this. How much energy do you have, potential energy, if you have a 10 kilogram object 1 meter above the Earth? So we just plug this stuff in. 10 kilograms is how heavy our object is. The acceleration, the gravity is 9.8, the height is 1, multiply those together, that'd be 98 joules of potential energy. Some of your stuff might make you solve for something besides energy, solve for one of these things. So let's do a little algebra together here. Same kind of question, but we're going to solve for the height of the block above the Earth. We lift the block up above Earth, it's got a certain amount of potential energy, and we're given the mass as well. And we know how high is it above the ground. So potential energy is mass times gravity times height. We have the potential energy with the mass, with the gravity. We don't have the height. So again, a little algebra background again to rearrange some things. If you want to switch sides, whenever you switch sides with a variable, you just flip it to the other side of the numerator denominator. So right now everything is in the numerator. Potential energy is on the numerator on the left side. Mass, gravity, height are on the numerator on the right side. If we want to get the height, solve for the height, we got to rearrange it so the h is all by himself. To do this, we can divide both sides by mass and gravity, which effectively just takes the mass of gravity, which is up in the numerator, and brings it down to the denominator on the other side. So going from here to here, you'll see that all we did is we took the stuff that was next to the h that was next to it and brought it to the other side of the equation, the equal sign, and put it below the potential energy. Now we can plug our stuff in. We have 98 joules of energy. The mass is 5, gravity is 9.8, solve for h, and that's 2 meters above. So that's just a little algebra background again. When it comes to food calories for potential energy, you'll find this on your cereal box, but every gram of fat has 9 calories. A gram of carbohydrates and proteins, both those things have 4 calories each. Food calories, every food calorie is actually 4,180 joules of energy. That's a big calorie, and a small calorie is 4.18 joules. This one is actually defined based off of water. In this class, we're not going to spend a lot of time talking about this. We're going to focus mostly on these things right here. So a sample question would look something like this. How much food calories are in a candy bar? 10 grams of fat, 4 grams of protein, 6 grams of carbohydrates. Total calories just equals the calories from everything combined. How much fat calories, how many protein calories, how many carbohydrate calories. So we have 10 grams of fat. Each one has 9 calories. 10 times 9 is 90 calories. 4 times 4 for the protein is another 16. 4 times 6 here is 24. Add those together. That would have 130 calories. So again, in this class, we're going to focus mostly on this right here. Kinetic energy is energy that's moving. So if you're moving, you have kinetic energy. The amount of energy you have depends on how fast are you moving and how heavy you are. Although speed is more important. In the equation, it ends up being that it's velocity squared. So it's half of the mass times your velocity squared will be the kinetic energy. Do note that mass needs to be in kilograms and velocity is in meters per second. So a sample question, how much energy in kinetic would a 40 kilogram boy running at 2 meters per second have? Well, kinetic energy equals half of the mass, half of 40 is 20, times the velocity squared. 2 squared is 4. 20 times 4 is 80 joules. Just like before, you might have questions that ask you to solve for something that's on the right side of the equation, and then you get to rearrange for it. So another sample question, how fast is the person running? If the person has 1,000 joules of kinetic energy and a mass of 100. You see, we plug our stuff in that we know the energy we have, 1,000 joules. We know the mass is 100. We don't have the velocity. And we want to solve for V. So we have kinetic energy equals 1/2 mv squared. In order to rearrange this, we're going to switch sides so the V is all by himself. We're going to take the 1, bring it down, bring the 2, bring it up, bring the m, bring it down. So when we switch sides, we're just take the m from up here, bring it down here, bring the 2 down here from the half, bring it up here. So then we put the numbers in after we rearrange our equation, and we still have a v squared there. So when we get to the end, we need to take the square root at the end. So it'd be square root of 20, 4.47 meters per second. Have a great day.